Welcome to Math TV with Professor V. This is a continuation on the lecture for section 2.3 that covers properties of functions. And in this lesson, we're going to learn about average rate of change and the equation of the secant line. So let's look at the definition for the average rate of change of a function, and then we'll talk about exactly what it represents. So notice here, if you have A and B, A not equal to B, or A different from B is another way we say that. These are two values that are in the domain of a function, y equals f of x. Then we say that the average rate of change of f from, now this is important, from A to B is defined as the following. So the average rate of change is equal to the change in y over the change in x. And since our function here is f of x, the change in y is equal to f of b minus f of a. And then the change in x is equal to b minus a. So a and b are x values, okay? Now, this formula should look eerily familiar, does it not? Change in y over change in x, you might say that's how we compute the slope of the line that goes through 2 points. And you're right. However, notice in this definition, we're not saying that f of x is a linear function. It's not a line necessarily. It can be, but this definition for average rate of change is applicable to all functions. Okay, not just linear ones, more fancy schmancy ones. So now we're going to look at why is there a connection between slope and average rate of change, and it comes down to the secant line. All right, so if we have 2 points on the graph of a function y equals f of x, and I have some arbitrary function graphed here. So this is our f of x. And notice it's not linear, right? It's not a line. This is y equals f of x. It can look different, of course, but it's just a function. It needs to still pass the vertical line test, okay? So here's good old f of x. So if 2 points on the graph of a function, and what are these 2 points? A comma f of a and b comma f of b. Here they are. Here's a f of a, here's b f of b. Then we say the line containing these 2 points is called the secant line. So this right here, the line containing these 2 points is the secant line to the curve here, y equals f of x. The word secant, the root is Latin secare, which means to cut. So you can see like it cuts through the curve, sort of, yeah? Okay. Now, if you were to compute the slope of this line, right, this secant line, I'm going to write secant, you would take the change in y over change in x. Normally we use this slope formula, right? This is the one you're probably more familiar with. Well, look at the points I have. I have here a f of a, so that's like x1, y1. And then I have b f of b, so that's basically your x2, y2. So then you end up with f of b minus f of a over b minus a. So the slope of the secant line is equal to the average rate of change of f from a to b. So average rate of change is the same thing as slope of the secant line to the curve. Later, when you study calculus, you're going to learn about what an instantaneous rate of change is, and that has a relationship or is equal to the slope of not the secant line, but the tangent line to the curve at a certain point. So we're going to build on this concept in the following course, but right now we're just going to lay the foundation, understand what a secant line is, it cuts through a curve at 2 points. Notice it could cut again over here. One time I got scolded for saying it crosses a function at 2 points. It could be more, but we only care about 2 points, okay? So, you know, we don't need to be nitpicking people for no reason. So here's the 2 points. Secant line cuts through, and we can find its slope. You don't even have to really think about average rate of change when you do that, but it is also equal to the average rate of change of our function from A to B. Okay, so all those terms are interchangeable. We're going to look at some exercises now, and just keep in mind the definitions because the actual problems are not too difficult to solve. All right, let's hop to it. So here's an example. G of x equals x squared plus 1. The problem says find the average rate of change from -1 to 2. So be careful here. It matters from A to B. So -1 is A and then 2 is B. Good? Okay. So let's remind ourselves what the formula is for average rate of change. Do you see it up above? Well, instead of f, our function is called g. So we're going to have g of b minus g of a over b minus a. So for this particular case, a and b are -1 and 2. So this is going to be g of 2 minus g of -1 over 2 minus -1. Now, if you want off to the side, we can compute what the function values are. Maybe let's do that so we don't overwhelm ourselves, huh? So g of 2, where do I get that? I'm just going to come right here, substitute in 2 for x. So that would be 2 squared plus 1, that's 5. And then g of -1, that's going to be -1 squared plus 1, so that's 2. All right, now I can substitute those in to the numerator. So g of 2 is 5, g of -1 is 2. What is this guy doing so crooked? Get with it. Okay, over 2 minus -1, that's 2 plus 1, so that's 3. We have 3 over 3, so that's 1. So that's the average rate of change from -1 to 2. All right, part A is done. Part B, find an equation of the secant line containing -1, g of -1, and 2, g of 2. Well, to get the equation of a line, you need two things. You need a slope and a point. And I actually already have the slope of the secant line because I have the average rate of change. So 1 is equal to the slope of the secant line. M secant equals 1. Great. All I need now is a point. Can I get a point from somewhere? Sure. You've got 2 to pick from, actually. Do you want to use -1 g of -1 or 2 g of 2? It's up to you. Both will give you the same equation of the line. It'll be correct. Let's just use 2g of 2 because it's positive. So here's my slope. The point I'm going to use is 2, and then g of 2, I have it right here, it's 5. And then how to put the equation of the line together, we're going to use point slope form. You remember y minus y1 equals m times x minus x1. So we'll have y minus 5 equals, m is just 1 times x minus 2. Adding 5 over to the other side, multiplying by 1 does nothing, so you don't really need to distribute. Just dump it, and then add 5, y equals x plus 3. So that's the equation of the secant line to the curve x squared plus 1. Okay? Very good. Should we graph it? I just thought of that right now. It might be satisfying. I say let's graph it. Okay. I'm freestyling right now. Let's do it. Okay. So x squared plus 1, we know that that's a parabola opening upward. It's been shifted up 1 unit. We'll get into more of that later. Okay. So I'm mostly going to draw this. If you don't know how to graph a parabola yet at all, then you could just go to like Desmos.com or something like that. 1, 2, 3, 4, 5. 1, 2, 3, 4. 1, 2, 3, 4. Okay, I'm going to plot the points here. -1, g of -1, 2, g of 2. So it's 2, 5, and -1, 2 that I'm going to plot. 2, 5, -1, 2. This is my secant line. Okay. And then the parabola, x squared plus 1, it's shifted up 1 unit, and then it also goes through those points. Remember? There's x squared plus 1. And then C, do you believe the equation of this secant line is x plus 3? X plus 3 means the y-intercept right here is at 3. Oh yeah, it for sure is. So here's x squared plus 1. They picked what A and B were. The average rate of change between these 2 points is 1. And then also the slope of this secant line is 1. Here's its equation. So that's basically what we did. Fabulous. Okay. Moving on, let's look at a couple other examples. If you're one of my students, these are on your practice exam. So good idea to practice. Find the average rate of change for the function between the given values. F of x equals rad 2x from 2 to 8. So again, this is A, this is B. Where you start is A. So the average rate of change, I wish we had like a symbol or an abbreviation for it. Average rate of change is going to equal f of 8 minus f of 2 over 8 minus 2. You can compute the function values off to the side, but let's try to just do it all within the problem. It shouldn't be too bad. So f of 8 is going to be square root of, just substitute in 8 for x right there. 2 times 8 minus square root f of 2 is 2 times 2 over 8 minus 2, that's 6. So let's clean up a wee bit more. This is rad 16 minus rad 4 over 6. Rad 16 is 4. Rad 4 is 2 over 6. So 4 minus 2, I have 2 over 6, and this simplifies to 1/3. That's it. And in this particular problem, they didn't ask us to do anything else, so we're done. Move on with your life. Okay, last example. Find an equation of the secant line containing 1 f of 1 and 2 f of 2. So we did something very similar already. If we want the equation of a line, not just the secant line, any line in math, you need two things. You need the slope. So I need the slope of the secant line, and then I need a point. Okay? Well, the slope of the secant line is equal to the average rate of change, so we'll go ahead and compute that. The slope of the secant line is equal to f of 2 minus f of 1 over 2 minus 1. Let's compute these function values off to the side. So f of 1 is 4 over, whoa. That's also an ugly 4. Excuse me, I need to fix it. I can't stand the sight of it. 4 over 1 plus 3, so that's 4 over 4, that's 1. And then f of 2, that's 4 over 2 plus 3, that's 5 in the denominator, so this is 4/5. Okay, lovely. Now plug that all back into the numerator. So f of 2 is 4/5 minus f of 1 is 1 over 2 minus 1 is 1. 4/5 minus 1, well, I know 1 is 5 over 5. So 4 over 5 minus 5 over 5 is negative 1/5. Over 1, I don't need to write it anymore. It's not doing anything. So here's the slope of my secant line. And then the second thing I said we needed was a point. Well, we've got 2 points. I know f of 1 is 1 and f of 2 is 4/5. You can use either one to write the equation of the line, starting with point slope form, but pick the one that's going to make life nicer. If I were you, I would pick 1, 1 because there's no fractions in it. Okay, so we're going to use 1, 1. That's 1 f of 1. Okay, here we go. So y minus y1 equals m times x minus x1. This is my x1, y1 basically. So we'll have y minus 1 equals negative 1/5 times x minus 1. Very good. Now from here we need to distribute. So y minus 1 equals negative 1/5 x plus 1/5. And then adding 1 to both sides. 1 is 5 over 5, right? Yes, yay fractions. So we're going to be left with y equals negative 1/5 x plus 1 over 5 plus 5 over 5 is 6 over 5. So this is the equation of the secant line containing those 2 points. Okay, later on in the semester, we'll learn how to graph this function. It's a rational function. It has a vertical asymptote. I know, so many spicy things we're going to learn. If you want for now to graph it, then you can just go online, go to desmos.com. They're not sponsoring me. I wish they did. And then you can graph this function. And then if you want to also enter in the equation here, then you can compare and make sure that you see the graph of this line crossing through these 2 points here. I'll leave that as an exploratory exercise for you to do. All right, that concludes the video. Hope you enjoyed it. Give it a thumbs up, subscribe if you haven't already, and I'll catch you guys later. Bye.